right, thank you, Roland, and thank you to everyone for being here at SteemFest. I'm super excited to be here with all of you, get to meet you all in person instead of just seeing your faces on the website. So please come up, say hi to me at some point. As Roland said, I'm Michael Vanderberg. I'm our lead blockchain developer at Steemit. I've been with Steemit from the very beginning, and essentially, if something has to do with the blockchain, I am in some form responsible for it. So that's the back end, the core of our technology. Without the blockchain, nothing else works. So it's pretty fun. We've had a very, very busy year with the blockchain. Just in the last year, late last 2016, we had hard fork 16, which seems like it was forever ago, which removed hyperinflation, and I think completely changed how all the economics worked and added so much extra stability. In 2017, we had Steem Simplicity, which removed a bunch of the esoteric rules of the blockchain, just cleaned things up. And then in the summer of this year, we had Steem Equality, which brought us all linear rewards. And we had a bunch of people asking for that for a really long time. So we're really happy to be able to finally do that. And we're not done at all with this year. We've been working on AppBase, which completely restructures our application framework. Everything is a module. It's all plug and play, and it's going to help us scale Steem to new levels that no blockchain has ever achieved. We've been testing it internally, and we're actually hoping that we'll be able to have a release in the next couple of weeks. So we're really excited about that. We're working on the next hard fork, Steem Velocity, which is going to allow people to mine accounts again. There will be subsidized account creation. We're going to remove the comment vote dust threshold, which is this really weird little rule that only brand new accounts ever run into. And all of these changes are aimed at making account creation easier, more scalable, and making that initial experience on the blockchain as good as it possibly can be for every Steemian. So we're really excited about that. And of course, we're working on smart media tokens. And we've actually expanded our blockchain team over the last couple of months. I think we're up to 7 developers just on the blockchain now. And so all of this we're able to work on in parallel and hopefully get this out as quickly as possible. And as Ned mentioned, we're going to have a testnet for SMTs. We actually just got that kind of wrapped up internally this last week. And so we're going to be launching this testnet incrementally with SMTs as we get features completed so that our external developers, all of you, can begin writing applications to use SMTs months or weeks before SMTs are released, so that you can be right there with us, they get released, and you've already got something ready for it. So we're really excited about that feedback loop and being able to communicate with the developers as we're completing SMTs. Overall, the dev team is really, really excited, and I think it's absolutely warranted. So this is Roadscape's TPS report from a couple weeks ago. And as you can see over in June, I guess Steem is the blue line. About in June is when we passed almost all the other blockchains to become the most active blockchain in the world and set ourselves up sort of as this new normal of about 700,000 transactions per day. That is the most active blockchain. And if I'm not mistaken, a couple weeks ago, we almost hit 1 million transactions in a 24-hour period. No blockchain's ever done that. And I am confident within a couple of months, we will pass that mark and Steem will make history yet again. Also, our daily comment counts are up and are continuing to rise. And so that just shows that we've got more and more people on the site. They're active, engagement is up. These are all good things. I could show you a whole lot more metrics that all show this same trend, but I think you kind of get the idea already. However, just because things going up doesn't mean everything going up is a good thing. This graph itself is how much space it requires to run one of our witness nodes. And actually, talking with a couple people yesterday, that is now up past 16 gigabytes. So just off the end of that chart was a sharp increase. And so this is the amount of space it takes to run the witness node. And this also directly impacts how much time it takes to get a node up and running. And we call that the reindex time to get from the genesis block to current. And while we don't necessarily think this is a problem, all this runs on a single machine. It won't be long before running a witness node becomes prohibitively expensive. And so we want to address those potential problems now before it impedes the growth of Steem. And that's primarily what I want to talk about today. We're going to do this and address this by modularizing the blockchain. I believe last year, Dan was talking about the blockchain fabric, and this is the refinement of that as we've been discussing this over the last year. And we're essentially going to break the blockchain up into smaller modules that can all be re-indexed independently. So that if we do an upgrade on one part of the blockchain, you don't have to re-index everything to get back up to a live state. This means administering a witness node becomes a much simpler task. As a result of this, it also means you'll be able to re-index in parallel. So the re-index times are going to be significantly shorter because of that. And eventually, we even want to treat the abstraction of a Steem node, or create that as an abstraction so that a node may actually be a distributed cluster of machines that all act as a single entity for the purposes of serving up state and consensus. So this will be a complete, the next stage after AppBase and a rework of our application framework that is going to support this. So how exactly are we going to do this? Talking with my team, we've kind of identified several types of state dependencies that exist right now in the blockchain. We've got a few that have to read state from another thing. So, for example, when you vote, you've got to know how much Steem power you have to know how impactful that vote is. So that requires reading state from potentially another part of the blockchain. And we've got a solution to this that we're calling Annotations. We'll get into that in a second. And then we also have what we're calling self-describing dependencies. An example of this is a reward balance, and later I'm going to show you how exactly that works. And we can gain huge advantages by running a node via a trustful system rather than trustless. And I'll also get into that. And then, of course, we've got state independence. Posting and trading limit orders don't have anything to do with each other, so they can happen at the same time anyway. And that's sort of our trivial case, but it is important to identify wherever such, independence occurs. These are very easy lines to modularize the blockchain on. So the blockchain annotations are simply, and this is to address our lock-stepping reads, are simply computational shortcuts. So when part of the consensus code needs to do a computation, we can just kind of save the result for later, and then when we re-index, we don't need to do those reads anymore. It'll save us time. These will all be generated locally, so they'll be trusted. They're not going to be sent across the distributed network, and this will allow us to break that lockstep re-indexing. However, it does require the original computation to create the annotation. So this is going to have limited use in the live network, but significant use for re-indexing. So it's primarily going to benefit us with managing the nodes rather than getting the original node up from scratch. So digging into kind of the meat is going to be these self-described operations. And I just, building up to sort of the punchline here of how this all works, just give a couple quick definitions to make sure we're all on the same page. when it comes down to it, a blockchain, right, is just a series of transactions. I'm sure you've all done a Google search for what is a blockchain at some point. And this is the ledger analogy, that everybody has a copy of the ledger. And for any given application, the rules of what that blockchain is, it determines how you interpret those transactions. And so when it comes down to it, the Steem blockchain itself is just the rule set that we've all agreed upon of how we're going to interpret those transactions. And that's what our consensus is. And so on our blockchain team, we very commonly talk about different levels of consensus. We have a hard consensus, which is saying if anybody breaks this rule, I'm going to reject the ledger. This is really important because you don't want someone sending someone else more Steem than they have. That's something that will cause you to reject that version of the ledger. Whenever we want to change those rules, that's when we have our hard forks, because everybody has to agree to change the rules at the same time. We have a soft consensus, which says, I'm not going to break this rule, but if someone else does, I will allow it. And these are our soft forks. They come out a lot more often to kind of help prevent maybe certain bugs or unintended behavior. All of our bandwidth algorithms, how we can do free transactions, are using the soft consensus. And then we also have sort of this interpreted state, which is just an opinion on the ledger, has no bearing on whether or not you're going to accept it or not. All of the reputation scores are an example of this, that they analyze your voting habits and who you vote on and who votes on you and comes up with the score. And really, as far as our optimizations are concerned, we're only concerned with hard and soft consensus. And in fact, most of what currently is interpreted state that it lives in the Steemd process, we are moving out to external services, and all of those are open source. So SBDS and HiveMind are great examples of what we're doing there. So we kind of thought to ourselves this question of what if we treated hard consensus as soft? And this is a very, very important question, because it kind of goes against everything that we know with a blockchain of we need to reject transactions if they don't agree with us. However, asking us this question allows us to gain significant technical improvements. Essentially, what would be a trustless system of you needing to validate these operations against everything else now becomes trustful. And specifically, you're trusting the witnesses not to lie to you effectively. So the witnesses become the final judge on what can and can't get in the blockchain. And so in order to attack Steem, you would either need to get 51% of the Steem power to vote in all of your own witnesses to do what you told them to, or you would need to convince 11 of the elected witnesses to lie to everyone else. This is actually not as dangerous as it would seem, because currently 50% of the Bitcoin hash power is controlled by 4 mining pools. So in order to attack Bitcoin, you would only need to convince 4 entities to collude rather than 11. And this gains a significant performance improvements because trust has less overhead than trustless. Hopefully I'll convince you that in the next couple of slides. But if you're a little bit wary of this mode of operation, the key here is running a node in a trustful mode is completely optional. Steem's still a blockchain. Everything is cryptographically verifiable. And so if you feel like your node can always choose to do all of the work to ensure that everything is checking out. So there's always that audibility for the witness to the witnesses. And we're actually already doing some of this stuff in the blockchain right now. What was it? I think in Steem Simplicity is when we added the reward balance. And this actually helps us solve some of these problems. So as an example, let's say Ned wants to claim his reward balance, right? What all do we actually need to know if that operation can succeed? Well, we need to know what Ned's posts were. We need to know who voted for him, We need to know what their steam power was to know how big those votes were. We also need to know their voting history so we know what their voting power was to know how big their votes were. And so you see that the amount of state you need to know just to verify this single action quickly gets out of control. However, the reward balance operation is very simple. This just says Ned wants to claim 1 Steem, 10 Steem dollars, and 9 Steem power. If you implicitly choose to trust the witnesses that this operation is valid, you now know what Ned's balance is. You can track what his trades are. You can do a whole another section of the blockchain just by choosing to trust the witnesses with this one set of information. And all of a sudden, a significant portion of what your node is spending trying to keep up with the live chain doesn't need to be done anymore. And that's where the true performance increase happens. So we are planning on adding more operations like this, where we are going to identify where these data dependencies exist so that we can further split up Steem. And furthermore, because we have this plan in place, SMTs are being designed from the ground up with this in mind, so that when this all gets in place, SMTs will scale along with everything else. And this is all going to be coming in 2018. Our team is working on it currently alongside SMTs and Hard Fork 20. And so we're really excited to get this out to you as quickly as we can. So thank you very much. And Roland, how are we on time? Do we have time for some questions?
Yeah.
Okay. Oh, anybody?
Can you go back for a second on the chart that had the number of transactions?
Yes.
After that, it's very key. And how can Steem do this versus the other chain? What's a simple explanation?
The software we're running on is more efficient than anyone else. It's also proof of stake. So, Bitcoin, you've got to wait for the blocks to confirm via hash power. So there's an artificial cap. That's why all the drama with SegWit 2x was huge, because it was a way to cut down on the transaction sizes in Bitcoin, increase the block size so that they could fit more there. So other blockchains have sort of imposed arbitrary limits. We don't have those. Ethereum has some strict technical limits in that it can't, get much more than like 3 to 5 transactions per second live. We have better software. We can handle more. Mm-hmm.
You said that there will be a possibility to mine on account, new account.
Yes.
Can you tell a little bit more how this will work? It will be possible for an average Joe to actually use it, or is it going to be mostly for developers at the beginning?
So our intent with mining is we do want an average Joe to be able to use it. If it becomes extremely popular, you may be sitting there mining for 2 weeks until you get an account. But we want it to be a tractable problem. Like, it should happen in a somewhat reasonable amount of time. The mining algorithm itself, as far as the difficulty will be, so I said the cost is going to be determined based on how many accounts were recently created. And so periods of time when there's a lot of account creation will be more difficult to mine an account. When there's very little account creation, it'll be easier to mine an account. So that rather than being it based on like a block interval or anything like that, like what Bitcoin does, the difficulty will be determined based on the current account creation rate.
It
talked a bit about this new framework for thinking about the nodes and making them more efficient and more modular. Could you clarify a little bit the difference between a full, thank you, clarify the difference between a full witness node that is running the full trust that you're talking about versus a witness node that is that it isn't doing, that's doing the old trustless system versus an API node versus just a normal node?
Yeah.
And like, how does that relate to an exchange or a tool that wants to have the blockchain status?
Yeah, that's a great question. So just to clarify, we're expecting that the witnesses are still going to have to run everything. Because the witnesses are the final judges and need to be able to reject blocks, they need to know the full consensus state. But if you're an exchange, you really don't care about who's posting things. And that's a huge chunk of the blockchain, both in computation and storage. And so long as they're trusting the witnesses, or perhaps partnering with another company who's running that part of the blockchain that will tell them, hey, this wasn't good, then they can run just, say, the balances and the limit orders so that they can tell whether or not someone's actually, the amount that they're depositing is an amount of esteem that they actually have. And the other thing there is a huge advantage is if we do a hard fork that changes how voting works again, then exchanges won't actually need to upgrade because their module, the modules they're running aren't actually changing. So that's something we want to do is breaking that apart means when we do have forks or hard forks and new releases, we're hoping to impact the fewest number of people as possible, just to keep everything running smoothly. Like I said, the other thing is like running a full node, maybe Busy and DTube, want to team up and they'll say, well, we'll run part of this and you run the other part. And so you can have partnerships there where everybody, you can sort of crowdsource your full node rather than needing one beefy server. So that's also part of this idea of we want to have these distributed nodes so that way, you've got your business partners you trust, and that should help make things more accessible. You just find friends to run a full node rather than finding money.
Final question. Yeah, thanks. Quick question. Can you please tell me the mechanical difference between a user-issued asset and a smart media token? In its essence, what is the difference between them?
Smart media tokens come with a whole lot more rules along with them, how they're dispersed. The smart media tokens is the framework by which the asset will behave, rather than, I think, a UIA is a freer, potentially less constrained, specifically in maybe a smart contract environment, what it can do.
Okay, thanks a lot, Michael, for this elaborating talk.
Thank you
very much.